Morning, everyone. Today we are going to continue practicing with polynomials. Today specifically, we're going to practice the three types of exercises that you are going to see on quiz number 2. Okay. Quiz number 2, we have three exercises, three different types, and that's that we are going to go over today. Any question before we start? Okay. So on last class, I gave you three exercises. Did you try those? If you try those, please tell me the answers. What are the answers? Tell me the zeros at least. What are the zero for F, the zero for H, and the zero for G? Anyone tried these exercises? Jacqueline, go ahead. Jacqueline, you there? I'm sorry, Jacqueline, I cannot hear you. I don't know if you are speaking, but sound doesn't come to my end. Okay. You can write in the chat. Okay. So here we have Mohammed, Amina, Benjamin, Jordan, Nicole, Timothy. Did you try any of these exercises? Okay, class, this is important because if you don't try the exercises, I cannot do more there. I want you to be successful in the class, but I need your cooperation. Okay, these are the exercises that we have been working with. You have my lectures available on Blackboard and YouTube, so you can follow them. If you don't have the answer for these exercises, do you have questions? Did you try those and you got stuck in a certain point on the exercise? Okay, let's check who is here. Mohammed, you there? Please unmute yourself and just say hello. Amina, are you here? Perfect. Benjamin. Benjamin, please unmute yourself. Thank you, Jordan. Benjamin, please unmute yourself and just say hello so I know that you are participating in the class. Okay, so we have only Jordan. Nicole, please unmute yourself and please tell me that you are participating in the class. Thank you, Nicole. Okay, so Mohammed is not here. Amin is here. Benjamin is not here. Jacqueline is here. Jordan is here. Nicole is here. Timothy, please unmute yourself around the chat. Let me know that you're here. Okay. Perfect. Okay, thank you. Mohammed, thank you. Yeah, I can hear you, Mom. Perfect. Good. Thank you so much. All right. Okay, so now, what about these exercises? Did you try those? These are the three exercises that I assigned you to practice on last lecture. Did you try those? Okay. So if you don't have questions, then going to move to the next exercises, the one that we are going to try. This is an exercise that you are going to see in the quiz. Okay, this one is degree of 4. Okay, this one is degree of 4, and this type of polynomial is the one that you are going to factor in the quiz. Okay, our quiz is on Wednesday. It's going to be a proctored quiz, and it's going to be graded by accuracy, not by completion. Okay, this is our first quiz, and it's going to be graded by accuracy. Okay, so you will have 20 minutes to solve this exercise. The goal of this exercise is to write it in the factor form. This one is a degree of 4. Okay, so it's the first step that you will do. Step number 1 will be all possible rational zeros. Okay, so how are we going to get the all possible rational zeros? We are going to get all the factor of 30. Okay, it's all the factor of 30, and those are 1 times 30 is 30, 2 times 15, 3 times 10, 5 times 6. Okay. Okay, so those are the factor of 30. Then the factor of the leading coefficient, which is just 1 plus 1 minus 1. When we combine P and Q, we are just going to copy what we have on P, because the only factors for the leading coefficient is just 1 and negative 1, so it doesn't change the values. Okay, so this is the first part, and this is what I want to see in order you to earn the points related to all possible rational zeros. Okay, step number 2. We are going to do a graph evaluation to know exactly which of these are the zeros, the real zeros of the rational zeros of this polynomial. So in that case, what I'm going to do, I will go to Desmos, and then I will evaluate my graph. Okay, so with my graph, we can see all the x-intercepts. All these are the real zeros. These are particular rational zeros. So in step number 2, what I want to do is just to identify the first zero. First rational zero. I like to start with from left to right, but you could start with any of these x-intercepts. First, a rational 0. To make things simple, let's select x equal positive 1, because working with 1 is easier than working with negative 5, and that this way you are seeing that we are selecting a first zero that is not necessarily on the left side of the graph. It's not necessarily an x-intercept at the left side of the graph. Step number 3, then we are going to create the linear factor of that 0 with that 0. Yes, I can go up to the equation. Okay. Did you write it, Timothy? Okay, perfect. So the linear factor, we are just going to take this value and we are going to put it here. That is the first linear factor that we got for the polynomial. Step number 4, we are going now to divide, to do synthetic division. Okay, so let me take all this. So this is the division that we are going to do. And in order to divide these two polynomials, what we are going to do is to do synthetic division. So we are going to simplify this. And here we are going to put the coefficients of our polynomial. 1, positive 5, make sure that everything is in order and that we have all the terms. 4, 3, 2, 1, 0. So we have all the terms. Negative 7, negative 29, and positive 30. The goal here is to get a 0 here. If we got a remainder of 0, that means that indeed x minus 1 is a linear factor of this polynomial. We go down, we add, we go up, we multiply. We go down, we add, we go up, we multiply. We go down, we add, we go up, we multiply. We go down, we add, we go up, we multiply, and we got our friend here, the 0. From the synthetic division, we can get the depressed equation, which is going to be a 1 degree less than the original degree. The original degree is 4. Now we are going to get a degree of 3. So because we are not getting into a quadratic equation yet, so this is going to be our first depressed equation. Okay, because our goal is to get to the quadratic equation to a degree of 2, so then we can implement the FOIL method or the quadratic formula. So we have 1x cubed, then plus 6x2, careful with the signs, minus 1x minus 30. So this is our depressed equation out of that first division, that first synthetic division. And what's interesting here is that the zeros that are carried, the zeros of the original polynomial are carried onto this polynomial as well. So that means that we don't need to go over and look the possible rational zero for this particular equation. We can go up. So, and from the graph evaluation, we have minus 5, minus 3, positive 1, and plus 2. We already use positive 1. It has an odd multiplicity because it's crossing, so we don't need to use net positive 1 again. Now we can select any of these 3 zeros that we have here. Okay, any of these 3 zeros that we have here are going to be also zeros of our depressed equation. So again, to make things simple, I'm going to pick positive 2. Okay, so positive 2 is going to be that zero, that first zero of this depressed equation here. Okay, so at this point, we are repeating the cycle. So the first zero of this polynomial that we have in screen. So let me put that step number 5. Step number 5. So that first zero that I just going to use is going to be x equal 2. It is a zero of this polynomial, and we are going to confirm that when we do the synthetic division. Okay. Step number 6, we continue working here. Step number 6 is going to be the linear factor. So the linear factor that we got from that zero is x minus 2. Step number 7. Then it's going to be the synthetic division. We're going to take this now polynomial, and we are going to divide this by x minus 2. To divide this is just taking 2 and the coefficient of our polynomial. Careful with the signs. And our goal here is to get a 0 here. Okay? Let's see if we can get a 0. So we go down, we add, so that's 1. We go up, we multiply. We go down, we add. We go up, we multiply. We go down, we add. We go up, we multiply. And yes, we got a 0 here. So we got a second depressed equation. And this is the depressed equation where we are going to stop the cycle because this is going to be a degree of 2. So x squared, 1 is the leading coefficient, plus 8x plus 15. Okay? So we are in a quadratic equation. Okay? So now we have two options. We can do the FOIL method, or we can do the quadratic formula method. Let's start with the FOIL method. Let me see if I can get these two linear factors. And indeed, I can cheat a little bit because the other two zeros are here, -5 and -3. So that means that we can get 3 and 5. 3 and 5. If we multiply them, we got 15. And if we add them, we got 8. So we can do the FOIL method. The FOIL method gives us the linear factor. These are the linear factors. Then the zeros are x plus 3 equals 0 or x plus 5 is equal 0. So we solve these two equations and we got that x is -3 and x is -5, or x is -5. So we have found all the zeros. We have 4 x-intercept. That means that we have 4 zeros. The degree of this polynomial is 0, and all the polynomials that we are working with have rational zeros. So we have found all the zeros of this polynomial. So what are those zeros? X equal 1, that gives us the linear factor of x minus 1. The other one is x equal 2, that gives us the linear factor of x minus 2. And then from the FOIL method, we got the two linear factor remainder. That remains. And then we got the zeros. So what you need to do in the exercise then is to finish. So the zeros are x equal 1, x equal 2, x equal -3, and x equal -5. And then we need to factor our polynomial. The leading coefficient of our polynomial is 1. Okay, so this is the polynomial that we need to factor. So the leading coefficient of this polynomial is 1. So we already know that we don't need to do anything with that. So we just go and we write the linear factor: x minus 1, x minus 2, x plus 3, and x plus 5. So we have factored our polynomial. We have identified the zeros, and we have the factor form here. Okay? And that's how we are going to complete this exercise. Okay? Any question? I am recording this, yes. Yes, I'm going to upload it on YouTube, yes. Okay? So I want you to do this one. You are going to see the exercise that is on the quiz is very similar to this one. So this is an exercise that you want to try. And if you have any question, this is the time for the question, because on quiz number 2, you are not going to make any question because I'm not going to answer questions regarding the material to class. Okay? So you will have 20 minutes to solve a similar exercise to this one. So this is an opportunity for you to try it. What I'm going to do is I'm going to give you 10 minutes to start. I'm going to mute myself. I'm going to turn off my camera. If you have questions, just mute yourself or write on the chat. Okay? Start working with this one. Careful that here you are not seeing all the terms. What happened is you are not seeing all the terms. What is the coefficient value of those terms? That's something that. Mm-hmm. 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 That. Mm-hmm. That's correct. Thank you, Timothy. That's what you want to do. Okay, so let's do this. I'm going to give you 10 minutes. Let's try this. Okay? Let me know if you have any question on the chat or you'll mute yourself. Okay, so before I go through our exercise, okay, Timothy, thank you. Before we go through all the steps, first, I want you to know what are your questions and which step you are, and how do you feel about this exercise. I need you to participate in class, actively participate in class. Other than that, I would not know which part you need help. Okay, so Timothy, you are stuck on, I think, on the depressed equation. Okay. 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 So that's what we are going to do. We are going to start with finding all the possible rational zeros, Benjamin. But Timothy, which zero did you use to do the static division? Okay, x equal 1. Okay, perfect. Okay, so step number 1. Let's find all the rational zeros. This is not the same step. Okay, step number 1. All possible rational zeros. Okay, so we have two numbers to consider for that. We have the leading coefficient and we have the constant value. Okay, we start with the constant value, so that is 9, and we need to find all the factors of 9. What are the factors? 1 times 9 equals 9. So 1 positive 1 and negative 1 is a factor. Also plus minus 9 is a factor. Other factor, 3 times 3 is equal 9. So plus and minus 3. Why do I select the plus and minus? Because if I do negative 1 times negative 9 is also positive 9. If I do negative 3 times negative 3 is also positive 9. So that's how I get the factors of those numbers. Okay, then we need to take into consideration the leading coefficient, but the leading coefficient is just 1, so that is plus minus 1, because only 1 times 1 gives us 1, or negative 1 times negative 1 gives us positive 1. Then we do the P over Q, but in the case where we have a leading coefficient equals of 1, this won't change, this expression won't change the values that we got on P. So the possible rational zeros here are positive 1, negative 1, positive 3, negative 3, positive 9, negative 9. Why? Because all these 1 over 1 is just 1, 3 over 1 is just 3, 9 over 1 is just 9. That is why when the leading coefficient is 1, our list of possible rational zeros are just the factors of the constant value. Okay? Benjamin, did I answer your questions? Okay. Mohammed, were you able to do this step by your own, by just following your notes? Great, perfect. So we are good with all possible rational zeros, okay? This is the first step, all possible rational zeros. Just focus on the constant value and the leading coefficient. Okay, step number 2. Okay, all of you are working on a device. So I think you are able to go to decimals or to your graphing calculator and then put this polynomial there. Okay, so that is going to be the second step. We are going to our graphing calculator, and what we are going to do is to put that polynomial here. And that is our graph. Let me put this a little bit bigger. Let me take out this. Okay, if we zoom out, we can see the entire shape of the graph. Okay, that is not important here. What is important are the x-intercept. How many x-intercept do we have? 1, 2, 3, 4. These are our x-intercepts. So let me take a screenshot of this so I can bring that into my notebook. So not the entire graph is not important in this step. It's just only the x-intercept. Why? Because the x-intercept are the zeros of the rational of the polynomial, are the real zeros. The x-intercept are the real zeros of the polynomial. Okay, so from here we can see that we have the 0x negative 3, the 0x negative 1, the 0x equals 1, and the 0x equals 3. Okay, so we already got the zeros, the rational zeros, the real zeros from the graph. The exercise here is that we want to write our polynomial in factor form. Okay. And in order to do that, we need to do the standard deviation to find the first equation and continue until we got a degree of 2, where we can use the FOIL method or the quadratic formula. Any question in this step? We are not done yet with this step, but any question with this? So one more time? Okay, perfect. So I think, Timothy, which 0 do you use first? Which is your first 0? Okay, so we are going to start with x equal 1. X equal 1 is going to be our first 0. Okay, first rational 0. So from that, we got our first linear factor. Step number 3 is our first linear factor. Our first linear factor, if x is equal 1, then that linear factor is going to be x minus 1. Okay? Step number 4 is where we are going to do the synthetic division. And that is where we are going to take our polynomial here, and we are going to divide this by this linear factor that we got on step number 3. Any of this. You will get a different depressed equation based on the 0 that you got here, but the final answer is going to be the same. Okay, which 0 do you use? Okay. So selecting x equal positive 1 is a better choice here if we want to keep things simple, because we don't have a negative, we don't have a factor that will change the value, because anything times 1 is just the same value. Okay, so selecting positive 1 is a good choice. Okay, here is the important part that you need to take into consideration, because we are seeing that we go from power of 4 to a power of 2 and then to the constant value. So there are gaps between these terms. That means that there's something that is missing. The third term and the first term. The third term is the one with x plus 3, x to the cube. So 0x cube, why 0? Because if we are not seeing something here, it means that the leading coefficient is 0. Then we simplify that term by just canceling it, omitting it to write it. So, and then plus 0x. Okay? How would you know if you are missing any terms? Well, you will go by the powers. 4, 3, 2, 1, and then the constant term. Okay? This is important. If you miss one term, then you are going to miss the synthetic derivation. Your synthetic derivation won't work because you need to take into consideration all the coefficients. Okay? The coefficients are this: 1, 0, -10, 0, and 9. So now we are ready to do our synthetic derivation. We are going to take the 0 that we got, so it's 1. And then we are going to write in the same order that we have here: 1, 0, -10, 0, and 9. So we are ready to do our synthetic derivation. Good question from the 0. Okay. We got our first 0, x equals 0, s equals 1, x equals 1. With that, we can create our linear factor x minus 1, x minus 1, okay? And that 1 goes here, okay? Now, we go down, we add 1. We go up, we multiply 1 times 1 is 1. We go down is 1 because we add 0 plus 1 is 1. 1 times 1 is 1 again. We go down, minus 10 plus 1, -9. We multiply 1 times -9, that gives us -9. We go down, we add, we got -9, we multiply now -9 times 1. This is -9 here, and we got our friend here, the 0. That 0 is the remainder. When we got this 0, we indeed have the confirmation that 1 is a 0 of our polynomial. Then we got the depressed equation. This depressed equation is going to be a degree of 3 because we are starting working with, okay, this is it's going to be degree of 3 because we started with a degree of 4. So when we do the synthetic derivation by a linear factor, when we divide by a linear factor, we go 1 degree less. So these are the coefficients of our now new polynomial, degree of 3, our degree of 3 polynomial. So 1, so we use this one, x cubed. Then plus 1, we use this one, x squared. Then minus 9 is this one, x. Then minus 9 again, and this is our depressed equation. Our first depressed equation is a degree of 3. Okay? So now what we need to do is our goal is again to find a 0 of this polynomial, use synthetic derivation to get a second depressed equation, and this depressed equation now is going to be a degree of 2. We don't need to do the all possible rational zeros with the depressed equation because the zeros that we got from the graph evaluation of the linear polynomial are going to be carried over to any depressed equation. We already used this one. We are not going to use this one. We are going to select any of these. Which one do you want me to use as a 0 for the first depressed equation? We cannot use 1 because we already used 1. Okay, let's use -1. So -1 is going to be our 0 for the first depressed equation. The first depressed equation. Okay, that's going to be the 0 for the first depressed equation. So our 0, let me put here step number 5. Okay, the 0 that we have selected for our q sub 1 is x equal to -1. Okay, we have taken that value from the graph evaluation of the polynomial. This gives us the following linear factor: x minus 1. We simplified this and we got x plus 1. Okay, step number 7, we are going to do the synthetic derivation. In this case, we are going to divide the depressed equation that we got here. Timothy, in this case, because I'm giving you zeros with a multiplicity of 1, you cannot use the 0 twice. Yeah. All the zeros that we are going to be working in these exercises are going to be multiplicity of 1. So that is the reason why we cannot use multiple times the same 0. If a 0 has a multiplicity of 2, 3, 4, so we can use as far as the multiplicity that same 0. Okay, but well, you can use it only once. If the multiplicity is only 1, it has a multiplicity of 1, then you can use that 0 to find all the linear factor just once. In these ones, you always are going to be able to find the quadratic equation by rational zeros. We are going to focus only on rational numbers. But there are other polynomials with irrational zeros and complex zeros. Okay? If we have irrational zero and complex zero, then we need to do other methods or other techniques in order to downgrade our polynomial into a quadratic and then to get all the linear factors. Okay, so let's do the synthetic derivation. The 0 that we got is -1, okay? So you can see that we always take the opposite value of what we have here in the linear factor, so -1. And then we have 3, 2, 1, oh, I missed something. -9, okay? I didn't copy the -9 here. So that is the complete depressed equation. See, that is a good idea always to review your polynomial, so that way you know that you have it in order and you have all the terms. Okay, so 1 is this one, then +1 is this one, -9 is this one, and then -9, and there is our synthetic derivation ready to start. So 1 go down is 1, go up, we multiply, we got -1, 0, because we add 1 plus -1 is 0, we go up, this is 0, down is -9, we go up, this is 9, and we got our friend here, there's 0. With this, we got the second depressed equation, and this depressed equation is a quadratic, because from a degree of 3, now we got a degree of 2. So 1x squared plus 0x minus 9. And look what we have here. This is interesting. Oh, so we can simplify this by just x squared minus 9. This, do you recognize this from your previous math classes? What is this? Mm-hmm. 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 So see that now we have found all the techniques. This is difference of squares, a difference of squares. Okay. If you know difference of squares, you can recognize this. Oh, this is only x plus 3 times x minus 3. Another way you can get to this point, yes, we can do FOIL or we can do the quadratic formula, but also we can do the following. Okay, this is just difference. The difference of square. If you know about difference of square, you are going to recognize this immediately. If not, you are good. What you can do is the following, because we are looking for the zeros. Remember that we are looking for the zeros. So if we are looking for the zeros, if I am here, well, let's find the zeros of this equation. X squared minus 9 equals 0. Let's solve for x. X squared equals 9, so we add both sides by 9. Then square root on both sides. When we take the square root, we need to add the plus and minus. And this is equal to plus minus 3. Oh, so those are the zeros. So plus minus 3 is a zero, is the two zeros of this equation. So from here, you can see that, well, we got the x plus 3 and we got the x minus 3. The linear factors, because if they are the zeros, if these are the zeros, well, the zeros are related with the linear factors, and this is another way to get those linear factors. Okay, all right, so we have finished with finding all the zeros or the linear factors. What you are going to do at the end is going to put, well, the zeros are x equals, what are the zeros that we got? The same that are here. See that since we are doing the graph evaluation, you already know what is going to be the goal. What I want to see is how you reach that. Okay? You are not going to be blindsided by this type of exercises. You will know the goal. Once you do the graph evaluation, oh, I know that I need to get to -3, to -1, to +1, and to +3. Okay, so there's are our zeros, and we already knew that from the second step. Okay, I'm not giving you exercises that you will go blindsided. You are going to be guided by the graph evaluation. What I'm looking for is this process where you do the synthetic division, where you identify the linear factor from the zeros, and so on. Okay, this is the most important part of this type of exercises, these steps. Okay, from here you can then write the factor form of our polynomial. The initial polynomial is this one. Okay. The leading coefficient is 1, so that it alleviates us from looking for the value of the leading coefficient. And this is the factor form of that polynomial. And you finish with this, you finish the exercise. Questions? Mohammed, your questions? Okay, perfect. Okay, so this is the exercise that is on the quiz is similar to this one. Okay, you will follow all these steps. The only thing that is going to be different are the actual number that I'm going to present there. Okay. Another exercise that you are going to see on the quiz is I'm going to give you a polynomial function, and then you need to write write the polynomial function, okay? And also, I need you to find, you have two objectives, you need to find the leading coefficient value. Let me write this better because this is okay. What you are going to do here? 1. Write the polynomial function. And 2, you need to find the leading coefficient value. Okay? So for this exercise and the quiz, we will have another 20 minutes again. Okay? From the previous one, you will have 20 minutes. From this one, you will also have 20 minutes. So I'm going to give you 10 minutes, 30 minutes. At 10 on 10, I'm going to get back here to see what you got. Okay? I'm going to give you a hint. The leading coefficient value is negative. Okay? All right. In 30 minutes, we get back here. I want to see your question or your answers. Okay? Start working with this. Do you see, before that, do you see this well? Is this clear? Can you read the numbers? Okay, thank you, Nicole. Perfect. All right. All right. So I think everyone here, what I saw on the chat, you got it right. Okay. So what I'm looking for in this type of exercise is that you tell me all this. First, degree, odd or even? Odd. How do we know that? Because of the end of our graph. Now, so we know that this is an odd degree because of the shape, but we can also get the leading coefficient sign, positive or negative. Positive. Remember that we have two shapes. We have this one and we have this one when the degree is odd. Okay? We have this shape, that means that the left end goes down and to the left side and the right side goes up and to the right side is when the leading coefficient is positive. When we have this shape where the left end goes up and to the left side and the right side goes down and to the right side, the leading coefficient is negative. This shape goes like this one. Okay, so the leading coefficient is negative. Okay? What else do we look for? Okay, so those are the zeros, yeah. But before, negative 18, is this an x-intercept or a y-intercept? Okay. Yeah, that could be a possibility. But this y-intercept, we are going to use it for identifying the leading coefficient value. In terms of the zeros of the polynomial are just the x-intercepts. Okay, careful with do not use the y-intercept as a zero because this is wrong. The y-intercept is just value of the function when the x value is equal to 0, and it's a good point to use for finding the leading coefficient value. Before we go to the zeros, I want you to focus on the turning points, because the turning points, we have two turning points. That means that at least our degree is 3. Could we have a degree of 4? Would it be possible to have a degree of 4? $5,000 is an even degree, right? 5,001. But what about 4? Could we have a degree of 4? It would be possible of this? Why not? 4 is even, and what's gonna happen? What from the graph? Can we the shape of the graph, the end point, the end behavior of the graph is not an even behavior. It's not a behavior that is related to that even degree. Okay, so we know that at least it has to be 3, but it could be 3, 5, 7, 9, and so on. Any other number that is odd. So now we have the x-intercepts, and we got from the x-intercepts, we got the zeros. We got the zeros, right? And from the 0, we got the linear factors and also their multiplicity. In the multiplicity need to be, in order, we need to have a multiplicity that meets the behavior of the graph on the x-intercepts, and we need to also have the sum of the power of each linear factor need to be equal to the degree that we are going to select. The degree that we are going to select is 3, is the easiest one. Okay, so zeros here. Zeros are -3, +1, and +2. Linear factors then are going to be x plus 3, x minus 1, and x minus 2. The power, the multiplicity slash power is going to be, we have a cross behavior in all of the x-intercepts. That means that all of these are going to be odd. So our choice is going to be 1, 1, 1, because when the sum of the 3, 1 is just 3. So we are going to write the polynomial function. Our polynomial function is, do not forget a. A is the leading coefficient. That is our first step here, our first goal. All this is important for your exercise, for your test. I need to see everything. This is your written work. If you miss this part and you got it right, you're not going to get points, because I need you to tell me all the steps in order to get to the right answer. Okay, you can get the right answer directly from the graph. Well, you can see, oh, -3, 1, 2. The answer doesn't matter here. What is most important is that you understand the properties of the polynomial. Okay, once more time, if you put the right answer but you don't show your written work, you don't show all these steps that I'm presenting here in the class, you are not going to get points. Okay, important to show me all the steps. Okay, so then we need to find the leading coefficient value, and that is where we are going to use the y-intercept. Any point on the graph is going to be okay, but if we can take advantage of the y-intercept, why not? This makes things easier. So this is the x value, this is the f of x value or the y value. So what we need to do is to substitute f of x with -18, and then all the x's is going to be 0. So 3, this is times 2, so we got -18 equals a times 6. We divide both sides, and the value of a is -3. Something that makes sense with what we got from the properties is -3. So we finish our exercise by -3 x plus 3 minus 1 minus x minus 1, x minus 2. And here is our final answer. This is the second type of exercise that you will be evaluated in the quiz. Okay? Any question with this one? Yeah? Good question. The 18 is here. This is the y-intercept. Okay, so this is a point on the graph. So to find the leading coefficient value, you need a point of the graph that is not an x-intercept. The best choice, if we can, is to use the y-intercept. So we have the y-intercept here, and this is the point that we are using. The- Say one more time. Yeah, if you don't have the y-intercept, then we can find any other point, but I'm going to provide you with that point. For example, I don't remember the exact value, but this could be a good point. Any point in the graph is going to be a point that we work for finding the leading coefficient value. The problem is that the point could be as far as very easy, like the y-intercept, or something very difficult when we start using fraction or decimals. So we want to avoid those kind of points. Okay, that's why I like to go for the y-intercept, which is the easiest point to use to find the leading coefficient value. Any other question here? Okay, so the last type of exercise that we are going to see on the quiz is this one. Find a polynomial of degree of 5, okay, the degree is going to be given, that has the following zeros, and the same for, we have two types of exercises, you are going to do one on the quiz. So let's try this one, and for this one you will have, for this type of exercise, you will have only 10 minutes in the quiz to do this one, okay? So what I want you to do is to give me the answer on the chat, and that will be all for today in terms of the class. But if you have more questions, we still have until 12 p.m. Okay, until 11:50 in the morning. So yeah, let's take. I'm going to give you 5 minutes. 5 minutes to do this one. Let me know your answers on the chat. Okay. Okay, Benjamin, thank you for your answers. Okay, perfect. Okay, so let's start with, let's begin with the first one. Let's see. Okay, so we need to write a polynomial. The degree is 5, okay, and we have the following zeros. So we are going to start with the zeros. So we have -3, we have 6, we have -7, can I write a 7? -7, go down, and we have 0, that's a 0. From the zeros, we can get what? The linear factors. We have x plus 3, we have x minus 6, we have x plus 7, and we have just x. Then we go for the multiplicity slash power, and we know that the power need to add to 5 because the degree is given. For the 0, 6, we have already a multiplicity. It's even, it's odd. So we have 3 more zeros that need a power, but those numbers need to add to 5. So what are the options that we have here? 1, 1, and 1. So the sum of these numbers is going to be 5. Now with this, okay, again, this is the written word that I want to see on your work. Again, we are going to write then our polynomial. So our polynomial, we go this way. Since we don't have any information, any point to get the leading coefficient, we are going to use a to represent the leading coefficient. X is this factor, then x plus 7, x minus 6 is the other factor. This has a power of 2 because the multiplicity is 2, it's even, and the power is 2, and x plus 3. Okay, check your answers. Benjamin, you got it right. Mohammed, you forgot to add the power of 2. And then, well, that's number 2, sorry. That's number 2. But I'm seeing that you have x, the factor x twice. Let's do the second one to see if the answer is correct. Okay, before we move to the second one, any question here? Any question? All right, so let's move to the other one. So zeros are 6, -3, 7, and 8, and 0, sorry. Linear factors are x minus 6, x plus 3, x minus 7, and x. No multiplicity is given, so multiplicity slash power, the only thing that matters here is that they need to add to 4. We have 4 linear factors, so 1 for each one. And then we write our our polynomial ax minus x minus 7, x plus 3, x minus 6. And that is the answer. So, Mohammed, your answer was correct, but you added one more factor. I think you confused x minus 0 and x, you put it twice, it's the same factor. So your answer should be just with the x, not with the last linear factor that you put there. All right. So that is going to be our quiz on Wednesday. You have this lecture. It's an open book. So please write your notes, get your notes ready for the quiz, and those notes also are going to be part of it. If you take advantage of that, you can write your project based on your notes. So the draft of your project that you should be that you are going to turn in on the 11, I believe. If you take advantage of these notes and these examples, these are good examples for your project. So you can write your notes in your project for the project. So you have your note for the quiz on Wednesday, which is an open book quiz, okay? And also you are taking advantage of your project. You are taking advantage of the requirements of your project. Or well, let me how the way. So you are doing two things at the same time. You are getting your notes ready for the quiz, and you are writing your project. Okay. So this is what I want to see on your project. This is an example of what I want to see on your project, because these are good examples that summarizes all the material that we have discussed in the previous lectures. Okay. This is also what you want to use as your notes for your assessments. Okay. So you have the video lectures, you have the examples, you have the practice. If you need more practice, you can just email me and I can give you more exercises, or you can access to my MATLAB and go to the book and look for those topics and do more exercises. You have options to get ready for the quiz. Okay. Next week is quiz, Friday is going to be practice, and then Monday 11 is going to be the day that you are going to submit the review. It's going to be the day that you are going to submit your first draft of the project, and then Wednesday, second Wednesday from today, is going to be our test number 2. Okay. It's Proctor. It's Proctor. Say one more time. No. It's going to be the same as we did with the quiz. And the quiz are proctored. I'm going to present the quiz, the exercises, and then you are going to give you time, and then you are going to finish all the exercise under that time. See, yeah, it's going to be represented here. Yeah. No. Let's make things simple. Let's get things simple. It's going to be presented here. You're going to see the exercises, and then you are going to write on your notebook or your device, and then you are going to submit on Blackboard. Okay? Any other questions? Okay, class. If there are no questions, happy 4th of July weekend. We'll see you on Wednesday. We have a quiz. Please, if you have questions, send me those questions via email. You have the lecture, the lecture to practice. Get ready your notes for the quiz. Start working with your project. Remember, you have a week and a few days to submit your first draft of the project. Okay. Your project is also going to help you to do the assessments, because on the project I want you to put all the information that is needed to do each exercise that is going to be evaluated. And these are the exercises that are going to be evaluated in quiz, in the practice, in the review. We have a little bit more because I always want to give you more, but on the test, these are exactly the topics that are going to be evaluated. So please, we have time to get ready for that test, okay? If you have questions, please feel free to reach out, to send me your questions, and I will do my best to answer within 24 hours and to give you an accurate answer for your questions. Okay? So thank you for being here. Bye-bye, everyone. Be safe, and happy 4th of July. Okay?